Right now, I would like to talk about ethers, esters, and organic acids. And those are different classes of organic compounds, and they have different properties, different functions, they react differently. However, there are certain similarities in their structure that make students to confuse them from time to time. So let's take a closer look at their functional groups and at their structure. First of all, I would like to remind you, in Table R, you do have functional group of every organic compounds that we've studied. Refer to it whenever you need it. But now, let's go to talk about ethers. Ethers are organic compounds in which two carbon chains are joined together by an oxygen atom bonded between two carbon atoms. Here is the general formula. So, on the left and on the right from the oxygen, you would see some alkyl groups attached. We already studied ethers. This is why I'm not going to spend too much time on them. Here are a couple examples for ethers: dimethyl ether and methyl ethyl ether. So you can see that in the middle, oxygen kind of extends left and right arms to alkyl groups. Over here in dimethyl ether, there are methyl and methyl groups on both sides of the oxygen. In methyl ethyl ether, you can see methyl and ethyl group extended on the left and on the right from the oxygen. So that would be our ethers. Now let's look at this compound. There is something ether-like in its structure. This oxygen that is holding on to two carbons on the left and on the right, of course, remind you of ether. However, look at this carbon over here. It's not only connected to the oxygen, but it also has another oxygen connected to it with a double bond. So over here, we are looking at the functional group of esters. This is an ester. Ester is a product of reaction of esterification when acid, organic acid, and alcohol reacted to produce this structure. So let me make blue everything that used to be acid and everything red that used to be alcohol. Here is the reaction that created this ester. Ethanoic acid met methanol, and they produced ester, methyl ethanoate, and water. So this is functional group of ester. Let's compare it to functional group of ether. Do you see the difference? Let me write the condensed formula of this ester in ether. Notice the difference. Okay, so over here we can see that this one is ester. It's a condensed formula of the ester. We see the functional group right here. This one is ether. The functional group is here. What about compound like this? CH3COOH. What kind of compound is that? I will go and highlight the functional groups of these compounds. Here is functional group of ester. Here's functional group of ether. And this is also functional group of an organic acid. Let me unfold it. Here's carbon with 3 hydrogens. I'm condensing the formula. Carbon that is connected to oxygen and hydroxyl group. And here's the highlighted functional group. COOH, carboxyl group that we see in organic acids. So it's ethanoic acid. I know they look kind of similar, but I still want to highlight the difference. Here's functional group of ester. of ether and of organic acid. Let's see what kind of questions might come your way on the test. Identify the element in ethyl ethanoate that makes it an organic compound. That is, of course, carbon. The entire organic chemistry is all about compounds of that include carbon. There is not a single organic molecule that does not contain that element. Write the empirical formula of this compound. Well, first let's find molecular formula, counting all the carbons, 4 carbons, counting all the hydrogens, 8, and counting all the oxygens. So that's molecular formula. Empirical formula will be the simplified version of it. So C2H4O. That would be the answer. And write the name of the class of organic compounds to which this compound belongs. Well, it's simple. It's ester, because we clearly see that there is ester functional group right here. Determine the number of electrons shared in bonds between hydrogen atom and carbon atom in the molecule. All connections between carbon and hydrogen is single line. Single line signifies 2 electrons.